So yesterday, I think we had everything except for the concentration of the spectator ions. Sound familiar? Okay. Spectator ions. No concussion today, Palmer? Okay. Did you hit your head? Okay. From oh. Okay. From up high, it looked like you just dove right into that stand. Like, oh, she dead. All right. So the last thing we have is the concentration, whoops, of the spectator ion, right? What were the spectator ions? I should just write them. Oh, see, that's why you can't drop. NO3 minus and Mg plus 2. Okay, so I didn't leave much space here. We'll just move them down here. The concentration can be found by taking their initial moles and dividing it by the total volume. I will say in liters. And that works for both of them, right? Now there'll be different numbers, but the instructions work for both. So I need to come up here. This is where it gets tricky. Make sure you look at the subscripts. So, well, we already did it, didn't we? We already did it because we had 0.5, but there was 3 NO3s or 2, sorry. So it's 0.75, whatever. We already have this was moles, wasn't it? That was really bad to put just an M. I apologize. My bad. My bad. Your father, I was in a meeting with him and he like bore his testimony about Boxer High and he started crying. I was touched. I was like, oh. Yeah, it was like an hour ago.
It's kind of funny because when I heard something from someone on their way to Nashville was that I'm a dirt bag of the sun. So.
A what?
Just kidding. Well, he's like, kill my dirt bag of the sun.
Well, he didn't bear his testimony about you. It was about Box Elder. Yes, ma'am. That is molarity. That's why this was dumb up here. Okay. So the initial moles of NO3 was 1.5 moles, and the volume is additive. So we had 0.5 liters and 0.3 liters. So we had a total of 0.8. And we had already done that 0.8 before. This isn't the best teaching because I just needed to finish it yesterday. Ran out of time. Okay, for Mg, it originally had 0.6 moles, right? So I'm going to come down here. The concentration of Mg plus 2 is 0.6 moles over 0.8 liters. All right, I haven't typed either one of those in. Anyone have that one? What's the top one? 1.875. And the bottom one? And then we'd be done. Now, if I'm good at reading the room, or at least how it's gone the last 15 years, if I gave you one, 99% of you would have no idea what to do. Okay. What's that? Facts. No cap. All right. So let's do one more together, and then I'll have you do one. Probably have one here somewhere. Ooh, here we go. So 300 milliliters. Forget that. What are you going to do right now? 0.3 liters and 0.1 liters. Let's just get that out of the way. So 0.3 liters of 0.6 molar aluminum nitrate is added to 0.1 liter of 0.4 molar sodium hydroxide. Find the mass of the precipitate and the concentration of the remaining ions in the solution. Melissa, don't make that face. That made me sad. Aluminum is +3. So there's a good start. We got to write out and balance the reaction, right? So we have aluminum That's a +3. Nitrate, it's a -1. You really should get to know nitrate. Nitrate or acetate are almost always delivering the cation that will form the precipitate. I don't know if that made any sense. Like in my head, that was a really good sentence, but oh well. Okay, now it's reacting with something hydroxide. I don't remember, right? What? All right, so Na, that's a +1, and then OH is a -1, so that's great. Now, this is a super typical precipitate forming reaction where I had something with nitrate that's going to form a precipitate, and I add family 1 metal and the anion, because that's always aqueous. Nitrate's always aqueous. So I have 2 solutions that when they're together make a precipitate. Will you tell your partner what you think the precipitate is? Oh boy, that's like 20 inches up on the group chat probably. Let me, actually, it's just AP with Tom. No one does anything but me. So you work on that and I'll work on this. Okay, so we know aluminum hydroxide. It is insoluble. Hydroxide is insoluble, except for with some things, and aluminum is not one of those. Oh, you found it? Yep. You're the man. All right, what's left over? That's twice I've done it that way because I ran out of space, but it's good enough, right? Because they're not together anyway, are they? They're spectator ions. Okay. Now, I don't know, we should balance it probably. So I have, I don't know, 3 OHs, so I better put a 3 right here, right? That makes 3 NAs, so I better put a 3. I'll just put it in front of both of them. You okay with that? It's kind of ugly, but there's 3 Na and NO3s, and then it would be good. 1, 3, 1, 3. All right, I would worry about the net ionic more. So I don't have to do like every single thing. If I just write out the net ionic, that's really the thing that's happening. So I have Al plus 3 OH minus goes to Al OH3 solid. I never did do this. It's okay if you don't, but I should probably. All right. So I've written out and balanced. The next thing I would find the moles, not molarity, I apologize again, the moles of each thing at the start. You okay with that? So like if I was doing this myself, I always do it just right here. And you don't have to, but I always go like this, like, or is it 0.018? It is 0.8? Okay. And then, and you can do it wherever you feel like. And this is 0.04, right? Okay, so I have 0.18 moles of this stuff, and I have 0.0, that looks like a 9, but it's a 4 moles. Anyone lost on where I got the numbers that I wrote in black ink? Okay, so to find the moles, we take the volume, which is liters, and we multiply it by the molarity, which is moles over liter. This is hard. Oh, we're pretty good. I was doing it off that reflection. Now, if I have the liters times the capital M, which is moles per liter, what cancels out? Liters, and it left me with moles. So that's why I just multiplied the two things together. Okay, now let's get a little bit rowdy. I'm just kidding. Okay, so if I have 0.18 moles of AlNO3, how many moles of Al plus 3 do I have? For aluminum, it's just the same answer because there's only one of them. You okay with that? So I had 0.18 moles. Now, Gabe, you're the one that said that, right?
Yeah.
He said 0.54, which is an answer. What would 0.54 be? That's how many moles of NO3 I'm going to have. I'm going to put it right here. Whoops. Oh my, Thomas Davidson. 0.18, 0.54. Does everyone understand where 0.54 came from? If you don't, please say something today. You're not the only one. So it was the total moles of all of this times the subscript. Okay. And then we had NaOH, and there was 0.04 moles of it, correct? So there's 0.04 moles of Na, and how much of OH? 0.04, because they only have one for both of their subscripts. Okay. Now, for my net ionic, I just need Al plus and OH minus. So what is OH minus? Don't multiply it by 3. When we find these things, they come from the subscripts. So it is just 0.04. Okay. Now I have a question for you. Look up here. You looking at me? Awesome. Is 0.04 3 times bigger than 0.18? No, that's like super obvious. It's smaller in the first place. So that would tell me which is your limiting reactant. The hydroxide, correct? Okay, you with me so far? Okay. So we know the amount of precipitate produced is dependent on the amount of limiting reactant. We said that a lot in the last unit. The amount of product depends on the amount of limiting reactant. Okay. Now, the amount of aluminum hydroxide produced is equal to 1/3 of 0.04. Explain that one to your partner. All right. Are we all right with that, sort of? So we only have 0.04 of hydroxide in the first place, right? But there's 3 that are necessary, right? Or there's 1 produced for every 3 used. Both of those are valid explanations. Okay, does anyone have 1/3 of 0.04? Is that 0.0133? Okay. Now, all these answers were moles, correct? So in my answer, I want to know the grams of AlOH3. I am now at a point where I can do it. When you see, ask your partner, do you remember how to find the grams of AlOH3 from where we are? Yeah, because it's 0.0133 moles. Okay, so raise your hands if you or your lab partner, if your group figured out how to do it. Raise your hands. Okay, so 2/3 did, and it's okay. Grams, one more time right here. Gosh dang. Oh, I have this thing in my hand. I don't even need to point. I got it right here. Grams of aluminum hydroxide produced is dependent on the moles. And the moles were dependent on the limiting reactant. We have the moles. It is 0.01333, or wherever you feel like rounding it. And that's moles. You don't have to do a picket fence, but for every 1 mole, how many grams of AlOH3 are there? That's from your periodic table. What? 89. That's too small. What? So say it louder. 78 seems too small, but maybe it is. Is it 78? So it's 78. Okay, my bad. It just seems like it'd be around 100. My bad. Which is that what you had, Rebecca? Okay. Okay. So we take that. Ainsley, do you have the answer? 1.0 what? Okay. Okay. Not a real big number. Uh-oh. No. You have a decimal for some reason. You have 0.78. It's okay. So kind of okay? Okay. So we've found the grams of our precipitate. It's taken a long time. Once we have this right here, my friends, once we have this, things roll pretty good. Okay. So the next thing we would do, we need to know the concentration of all the rest of the stuff. One of them is equal to 0. Tell your partner which one is equal to 0. In word form, tell them why. That has nothing to do with math. Okay, so it's not in the solution anymore. Does that mean it's gone? No, it's in the precipitate. It's locked into the solid now. So OH is still there. It's just not floating around in the liquid anymore. It's at the bottom. All right. Then, I don't know, what ion do you want to do next? All right, Al plus 3. Typically, on your exam, you'll get them all right but that one. And that's okay. You can still get an A and get the excess reactant wrong. Okay, here's what's kind of nice, my friends. We had 0.18 moles at the start, right? This is a 1, and this is a 1 right here, right? So the amount used, we already found that. Did we not? We found, since it has the same coefficient, we've already found the amount used. So I have the amount I started with, subtract that. So if you have the moles of your precipitate and it's a 1-to-1, then you just subtract it. So I had 0.18 moles. That was my initial. I subtract my used. You okay with that? My used was, I'm just going to say 0.0133. I'm sick of writing threes. Okay. Now, don't just say that's the answer. And that's really common. Oh, you're not who I thought would be here. I mean, welcome. But I'm used to a different person coming in a half hour late. Based on your hair, it's for a completely different reason too. Okay. Why is what I'm about to write here not the answer? I'm looking for concentration. So whatever this number is, I better divide it by 0.5, or is it 0.4? Sorry. I better divide it by 0.4 liters. Now, Seth, do you know where that came from? Okay, most people don't. Look right here. The two volumes I added were 0.3 and 0.1. So in my beaker now, I have 0.4 liters. That's my denominator. Okay. That will be my denominator for all of the molarity calculations. So what was 0.18 minus 0.0133? Anyone still have that in their calculator? And divide that by 4, and I get right? Well, now I got maybe both right there, huh? Yeah, I can cheat. Just kidding, I would not. That one's harder. Now they're all there. Yep. Take your best guess. Okay, I have 2 parts left, and they're not hard usually. Spectator ions. So I had Na plus, and I had NO3 minus probably, right? I already found their original moles. Na plus was 0.04, wasn't it? If I remember right. And I divide that by 0.4. I get 0.0, just 0.1, right? And then NO3 was at 0.54 or 5.6, 5.4 over 0.4, and I get 1.35. Whew. I know that was a ton of fun for me. I don't know about you guys. How much of a paper did that take? Half-ish? None? Preston probably wrote 2 lines. No, like 6 lines. Okay, it's a very orderly process with a ton of places to screw up. Like, I'm aware of that. These are frustrating because you do all that work and you're like, oh man, in my calculator I put 0.4 instead of 0.04, like way up here. Like, pretend you got 0.4 on accident because you can't read very well. Like, you got every single thing wrong on one little mistake. Okay, if you, when you do this test, write your math really clear so I can find ways to give you points. It's normal. That's not even, that's like whatever. Yeah, okay, that was fun. Yeah, you ready to work on one on your own? Or you can work on it with your partners as long as there's some splaining to do. All right.
That one.
All right. And I'll just take a 20-minute nap. All right, I had forgotten to record the answers. So here are the answers. If you want to see how, here's some paper with some work. So if you're a video person, you can pause it and look. This is done my old way, which took more time. So you're like, well, that's different. Well, it's the same, it's just written out different. Okay, what was the question? Someone was there, their hand. Oh yeah, always. You guys don't need to ask me permission to go to the bathroom. That's fine with me. Okay, so give this a shot. This will look extremely similar to the test question. There is more to this test question. There's letter F. It says, what would the mass of the precipitate be? It should also say, what's the concentration of any remaining ion? So it's just what we're doing. You don't have to work it out in those steps, but on the test it'll look like that. Do you remember that species means the stuff? No, AG is a +1. But on the right side, there would be 2. All right, the bell will ring, video people, so this is the end of today.